This question comes from a user who asks, what if you tried to print every YouTube video transcript? If you are looking to create a physical archive of the internet's most popular video platform, you should probably start by buying a very large forest. While printing out the English Wikipedia is a project some have actually considered, scaling that up to YouTube moves us quickly from a quirky art project to a planetary-scale catastrophe. To understand the scope, we first have to look at the current king of printed information. Wikipedia receives about 100 edits per minute, and you would only need about 6 printers running at any given time to keep pace with those changes. However, YouTube is a much larger beast. If we assume the average video contains thousands of words, the sheer volume of paper would quickly overwhelm any library on Earth. To handle the logistics, we have to assume you have invented some kind of money-summoning magic spell to pay for the equipment. Even then, the ink cartridges would be an absolute nightmare. For a typical inkjet printer, the real-life cost of ink is roughly 5 to 10 cents per page. While printing Wikipedia might cost $10,000 per day in ink, a YouTube transcript project would likely cost millions of dollars every single hour. You would eventually want to invest in a laser printer to save money, but in just a month or two, this project could end up costing you more than the GDP of a small nation. Then there is the problem of where to put the paper. Most people think of a pile of paper as a static object, but a pile of transcripts this large would not stay a pile for long. Much like the 1919 Boston molasses disaster, a large mass of material that lacks internal strength will eventually collapse and spread outward as a wave. This wave of paper would carry a staggering amount of momentum, scouring the landscape in an expanding ring. If you were standing nearby, you would be engulfed in seconds. Even if you built a wall to contain the transcripts, you would be in serious danger of violating Section 1806 of the New York City Building Code regarding the allowable load-bearing values of soils and rocks. If you decided to clear your backlog by accelerating the paper out of the printers at 90% the speed of light, things would get even worse. At these speeds, the ideas of aerodynamics no longer apply. The paper would smack into air molecules so hard that the atomic nuclei would actually fuse, releasing a burst of gamma rays and scattered subatomic particles. This would turn the air in your print room into an expanding bubble of incandescent plasma. This process, known as laser ablation, is actually a promising method for spacecraft propulsion, but in a print shop, it just means you've created a sizable crater centered a few hundred feet behind the former location of your desk. In the end, while it is a great goal to recover seemingly wasted energy or information, printing YouTube is a horrible idea. The heat and light from your relativistic paper jet would quickly raise the temperature of the planet and render the whole place uninhabitable. You would find yourself in very big trouble with the International Niagara Committee, or whatever governing body manages planetary-scale paper waste. Just as the Death Star caused a magnitude 18 earthquake on Alderaan, your print job would effectively destroy the world, and you would be better off sticking to digital.